In this figure, we can see the scenario for 5G multi-edge application continuity. Edge 1, associated to tracking area code, TAC1, is connected to GNB1, UPF1 and runs application app1 locally. Edge 2, associated to TAC2, is connected to GNB2, UPF2 and also runs application app1. A vehicle, using services from application app1, moves from TAC1 to TAC2, hence across different instances of the same app. This must be transparent to the vehicle. For this demo, app1 is a video streaming application, which streams one video in Edge 1 and a different video in Edge 2. The application runs on a MEC, multi-access edge computing, environment that is provided by Edge Gallery. At start, the vehicle, UE1, connects to GNB1, TAC1, and the data traffic is delivered by UPF1 to the edge node specific for that location. When the vehicle has made the handover from GNB1 to GNB2, TAC2, the data traffic is delivered by the UPF2 to the closest edge node, Edge 2. The objective is that the application access is transparent to the user in the vehicle, independently of its location, by using the same URL. To enable seamless communication between the MEC environment and the network, we implement a FLOYD network plugin, following the Edge Gallery plugin approach for the MP2 interface. We use a travel ping, UPF, plugin named VPP CloudNet. Basically, this allows DNAT, SNAT for cloud scenarios where virtual IP addresses are mapped to real ones. To do that, we set up rules for that plugin in both edges for mapping the same virtual IP to two real IPs. Here we can see an example, where a client requests a virtual IP, and the traffic is translated to a real IP from that edge. We also have DNS rules to use a domain name that point to this virtual IP. The DNS server is provided to the user when he establishes the PDU session. In the next minutes, we will describe how to add and instantiate an application in Edge Gallery. This is the Edge Gallery GUI. Edge Gallery is a 5G MEC open-source edge computing platform. First, we need to log in, then go to incubation. In incubation, we have 4 steps. The first step is to add the basic application information, such as its name, version, provider, load type, architecture, industry, app type, logo, guide document and description. The second step is to add the YAML script with the information for the VM container instantiation. In this specific case, the application image is a container and, thus, the YAML is used for Kubernetes, with deployment and service. When the script is uploaded, the parameters and the syntax are checked, and is automatically created in a package which includes 2 new files, chart and values. In this step, it is also possible to add traffic rules, DNS rules and check the application instantiation in a sandbox, previously configured, similar to an edge, or can be one of the edges. As a side note, the container image needs to be added to Harbor, outside the GUI environment. In the third step, build and preview are realized. It is possible to check the basic information, traffic rules and DNS rules. The fourth step is to make a test scenario, that is a group of tests. Some different scenarios are already provided, but it is possible to create new tests and new scenarios. The common scenario is composed of tens of tests grouped in 4 areas: compliance, sandbox, security, and performance. In the end, it is possible to see a test report, export to PDF, and if all the tests were successful, it is possible to publish in the App Store. When the publishing process is done, it is possible to select the application in the App Store and see the application details, add comments, and download. In MECM, MEC management, it is possible to synchronize with the App Store and select the desired application to be installed. After the synchronization process, the application can be selected and distributed to the different edges. In this case, we distribute to the 2 edges available. When the application is instantiated, it is possible to see its status in the app instance list. In the next minutes, we will show how the scenario presented before works in practice. First, we start the GNB1, TAC1, and we start the UE. This UE represents our vehicle that connects to the first GNB and gets the IP 172.21.216.35. In the UPF1, we can see that the PDU session is established. In this moment, we can reach the internet. To add the rules, we need to go to the Edge Gallery GUI, login, and go to the application list. We can see the two instances of the same application running in the two edges. We can see in the list of edge nodes that edge 1 has the IP 172.21.217.118 and edge 2 the IP 172.21.217.119. We can also see that both edges are active and running. In this moment, we need to add rules for each application instance. To do that, we go to Traffic Rules and add a new rule to do the Cloud NAT to edge 1. Then we need to add a filter where all the TCP traffic from port 30,153 goes to the virtual IP 30.30.30.30. Next, we need to map this virtual IP into the edge real IP 172.21.217.118. Once we do this, through the MP2 interface from Edge Gallery, we receive a request in the UPF1. We also need to add the reverse rule. Add a filter, where all the TCP traffic from port 30,153 goes to real IP 172.21.217.118. And map this real IP into the virtual IP 30.30.30.30. We need to add a route in the UE to make this traffic go to the correct interface. Now it is showtime. We can see this working in the VLC. Let's start our stream from virtual IP and the correct port. You can see the video that is specific from the Edge 1. The Edge Gallery also supports DNS rules, and we can add a rule for mapping the domain name FLOYD.tv to the virtual IP 30.30.30.30. We need to change the DNS server, because it is a VM, to the Edge Gallery DNS server 172.21.217.117. Now, we can see the stream using the domain name. In this moment, the vehicle makes the handover. For that, we need to stop GNB1, start GNB2, TAC2, and keep the same UE. The UE gets IP 172.21.216.134. We need to add a route in the UE to make this traffic go to the correct interface. If we try to see the streaming, this will not work, obviously. We need to add the rules to the Edge Gallery, as we have done for the Edge 1. To do that, we go to the Traffic Rules and add a new rule to do Cloud NAT to Edge 2. Then we need to add a filter where all the TCP traffic from port 30,153 goes to the virtual IP 30.30.30.30. Next, we need to map this virtual IP into the Edge real IP 172.21.217.119. Once we do this, through the MP2 interface from Edge Gallery, we receive a request in the UPF2. We also need to add the reverse rule. Add a filter, where all the TCP traffic from port 30,153 goes to real IP 172.21.217.119. And map this real IP into the virtual IP 30.30.30.30. You can see the video that is specific to Edge 2, different from the previous. In this moment, we can't see the stream using the domain name. We need to change the DNS server first. Now, we can see the stream using the domain name. We can easily do a handover to GNB1 and see the video from Edge 1. And we can do the handover back to GNB2 and see the video from Edge 2.